Video is going to be part one of two videos from this week, September 28th. And so in this first video, what I'm going to do is I'm going to step back and go through section 0. Recall that section 0 was just a section that we provided before the course started, which covered mathematical preliminaries, but which we didn't provide section videos on. And so what I'm going to do in this video is walk through one part of section 0, particularly the part regarding percentage changes and how to do them for various functions, and in particular, that's going to be useful to the material that we've seen in the specific factors model. And so, in the specific factors model, a sort of representative question that you might be asked is to examine how a change in relative prices is going to affect the relative share of labor in each sector, where you'll be given like how much the relative prices have changed in terms of percentages, and then you want to figure out how much relative labor in each sector has changed as in terms of percentages as well. And so to answer questions like that, it's going to be useful to review the relevant rules for percentage changes of variables. Okay, so just so we're all on the same page, suppose that a variable is going to change from its initial value of x to x prime, its new value. Then the change in x is just going to be given by delta x, or triangle x, which is defined to be, which is the triple equal sign, delta x minus x. So then, if we just want to go and we want to define the percentage change in x, then it's just going to be the new value of x, x prime, minus the old value of x over the old value. And that will tell us how much has changed. But to get that in terms of percentages, then we just multiply that by 100 and call it percent. And suppose that we have that x's initial value was 3 and x's new value is 4. So by what percentage does x change by? Okay, well, what we want to do from this rule is we want to take the new value of x minus the old over the old value. And so in this case, that's going to be 4 minus 3 all over 3, or 1/3. Okay, so we know that it's going to increase by 0.33. To write this, where the 3 is repeating. But to write this in terms of percentages, recall that we just want to multiply by 100 and then call it percent. And so then what that will give us, it'll give us that x has increased by 33.33333%. Okay, so that's the quick walkthrough of how to calculate percentage changes. Likewise, if we know that x is changed by z%, then the new value is going to be given by x prime, which is equal to x times 1 plus z over 100. And so that will be how we could work backwards to find a new value if we know the percentage change. So now what I'm going to move on to is I'm going to move on to thinking about percentage changes of multiplicative functions of values. So now suppose y is a function of n variables, x1, x2, so on and so forth until we get to xn, defined as y equal to x1 to the alpha times x2 to the alpha 2, and so on and so forth until we reach xn raised to the alpha n. Well then, the percentage change in y can be approximated as a function of the percentage change in x1, the percentage change in x2, and so on and so forth until we get to xn in the following way. The percentage change of y will be approximated by alpha 1 times the percentage change in x1 plus alpha 2 times the percentage change in x2, and so on and so forth until we get to alpha n times the percentage change in xn. There are a couple special cases worth noting. So suppose that y is equal to k times x raised to alpha, where k is a constant. Then the percentage change in y is just given by alpha times the percentage change in x. So to give a concrete example here, suppose that y is equal to 3 times x squared. Then if I define the percentage change in x in the following way, so note that on the slides it's written that the percentage change in x is given by the new value of x minus the old over the old times 100%. Well, I'm just going to define that to be the percentage change in x more concretely. Okay? So, suppose that x increases 10%. By what does y change by? Well, then we know that the percentage change in y is just going to be given by, well, we can ignore this 3 because 3 is a constant. So all we care about is pulling down the exponent on x, so 2, times the percentage change in x. And so if x increases by 10%, then it's just going to be 2 times 10%. And so the percentage change in y is just going to be 20%. So in sum, we know that y increases 20%. Okay? Moving on with the other cases, we can suppose that y is equal to x1 times x2. Then going back to the general rule for the percentage change of a multiplicative function of variables, we know that x1 times x2 is essentially the same as saying that x1 and x2 both have exponents of 1. And so, simply stated, the percentage change in y is just going to be approximated by the percentage change in x1 plus the percentage change in x2. The more useful rule is going to, or special case, is going to be when y is a fraction of x1 over x2. Then, implicitly, what this is saying is that y is equal to x1 raised to the 1 times x2 raised to the minus 1. That's the case because x2 is in the denominator of this fraction. And so, applying the same general rule here with alpha 1 equal to 1 and alpha 2 equal to negative 1, we have that the percentage change in y is approximated by the percentage change in x1 minus the percentage change in x2. So let's give just an example, just so you're familiar with how to apply these rules, particularly with a function that's going to look very similar to the ones that you're going to see in the specific factors model. So suppose that y is equal to x1 cubed over x2 raised to the power of 2. And suppose that x1 increases by 2% and that x2 decreases by 1%. Okay? How much does y change? Okay, so using the multiplicative rule, we know that the percentage change in y is just going to be given by 3 times the percentage change in x1. And then here we take the exponent 2, but remember it's in the denominator, so it would be negative 2 times the percentage change in x2. Okay? So here, just filling in for the percentage changes, we know that the percentage change in x1 is just going to be 2% minus 2 times the percentage change in x2. So if we plug in for x2, what do we get? Well, we get that x2 decreases by negative 1%. So what we want to plug in here is we want to plug in negative 1%. Okay? 3 times 2% is just 6%, and then negative 2 times negative 1% implies those negative signs cancel out, and we get a plus 2. So in total, what percentage does y change by? It changes by 8%. In particular, y has increased by 8%. And so note that because x2 is decreasing, but it's in the denominator, it's increased y. And so it's increased it by more than just the increase in x1. It's bumped it up by an additional 2%, so that y has changed 8% in total. Okay, and so these in particular, if you want to take away something, I'd say the rule that you ignore constants when thinking about percentage changes, as well as this general rule for the percentage changes approximations of multiplicative functions of variables are going to be the most useful for these specific factor model type questions where they ask you if one variable changes by a given percent, what the other variable changes by. So I hope this has been helpful in giving you the knowledge to work through some of these types of questions, and I'll see you in the section 5 video.